Here's something most people get wrong about space travel. It didn't start with NASA. It didn't start with rockets. It didn't even start with engineers. It started with a guy watching an apple fall. And what he realized in that moment would eventually put humans on the moon. But not because anyone wanted to explore, because everyone was terrified of each other. This is the story of how space travel actually began, and it's way stranger, messier, and more brutal than the history books usually admit. Because the same technology that let us walk on another world was designed to destroy cities. Let's rewind. In the late 1600s, Isaac Newton had a thought that seemed completely useless at the time. He was thinking about gravity, the force pulling objects toward Earth. And he realized something wild. The moon wasn't floating, it was falling, constantly. It was falling toward Earth, but moving sideways fast enough to keep missing. Like throwing a ball so hard it curves around the planet instead of hitting the ground. Newton even sketched it out, a giant cannon on top of a mountain, firing a cannonball so fast it would circle the Earth forever. That sketch was the first diagram of orbit. But here's the thing. Newton had the math, he didn't have the technology. And for the next 200 years, that idea just sat there, a curiosity, a thought experiment, until someone with nothing to lose decided to take it seriously. His name was Konstantin Tsiolkovsky, a Russian school teacher, partially deaf, self-taught, living in a small town most people had never heard of. He never built a rocket, he never left Russia, he never saw space. But in 1903, he published something that changed the trajectory of human history. The rocket equation, the formula that explains how rockets actually work. And what Tsiolkovsky realized, sitting alone in his study, doing the math by hand, was this. If you want to escape Earth, you don't need wings, you need speed. Enormous, ridiculous, physics-defying speed. And the only way to get that speed was liquid fuel burned in stages. He wrote about space stations, multi-stage rockets, orbiting colonies. People thought he was insane, but he wasn't guessing, he was calculating. And once the math exists, the future becomes inevitable. Across the world, others started playing with the same dangerous ideas. In the United States, a physicist named Robert Goddard launched the first liquid-fueled rocket in 1926. It flew for 2.5 seconds. It traveled 41 feet, shorter than a school bus. Newspapers mocked him. One headline literally laughed at the idea that rockets could work in space because there was no air to push against. They were embarrassingly wrong. Rockets don't push against air. They push against physics. Meanwhile, in Germany, a young engineer named Wernher von Braun became obsessed with spaceflight. But the world he grew up in wasn't dreaming about exploration. It was preparing for war. And here's the uncomfortable truth most space documentaries gloss over. Space travel was born in conflict. World War II turned rockets from experiments into weapons. Germany developed the V-2, the first long-range guided ballistic missile. It was also the first human-made object to reach the edge of space. It climbed over 50 miles high, it traveled faster than sound, and it was a weapon of terror. Thousands of V-2s were launched at London, Antwerp, and other cities. Thousands of people died. But when the war ended, something strange happened. The United States and the Soviet Union didn't just divide territory, they divided the scientists. Both sides captured German rocket engineers, both sides seized blueprints, and both sides realized the same terrifying thing. If a rocket can cross a continent, it can reach orbit. And if it can reach orbit, it can change the balance of power on Earth. That's when space stopped being a dream and became a race. October 4th, 1957. The Soviet Union launched something the size of a beach ball into orbit. It didn't carry a camera. It didn't carry a human. It carried a beep. Sputnik 1, a simple radio transmitter circling Earth every 96 minutes. But that beep, that monotonous robotic pulse, echoed across the planet like a warning siren, because it proved orbit was real. It proved rockets worked. It proved the Soviets had the technology to launch something into space. And if they could launch a satellite, they could launch a nuclear warhead the same way. Panic seized Americans. Space had officially become strategic. The sky was no longer a ceiling. It was a battlefield. 4 years later, the Soviets did something even more radical. They launched a human. April 12, 1961. Yuri Gagarin climbed into a metal capsule barely larger than a coffin, strapped to a rocket filled with explosive fuel, and let them light it. He orbited Earth once, 108 minutes. But those 108 minutes shattered every psychological barrier humans had about leaving the planet. Because Gagarin looked down and saw something no human had ever seen before: Earth from above. Not as a map, not as a collection of nations, but as a sphere, fragile, borderless, blue. And when he came back, he said something that still haunts space historians. The Earth is blue. How wonderful. It is amazing. The race had shifted. The Soviets weren't just ahead, they were winning. President J.F. Kennedy stood in front of Congress and made a promise that sounded like science fiction: land a man on the moon and return him safely before the decade ends. Not because it was easy, not because it was safe, because it was a statement, a geopolitical flex disguised as exploration. The Apollo program wasn't just about science, it was about proving technological superiority. It was saying, anything you can do, we can do bigger. And NASA built the Saturn V, the most powerful machine ever constructed. 363 feet tall, burning 20 tons of fuel per second at liftoff. It wasn't elegant, it was a controlled explosion pointed at the sky. And on July 20th, 1969, Neil Armstrong stepped on the moon. One small step for man, one giant leap for mankind. But consider what had actually happened. In less than 70 years, humans went from barely flying powered airplanes to walking on another world. That leap wasn't gradual, it was violent, fueled by fear, pride, rivalry, and raw engineering ambition. But here's the part of the story that changes everything. Space travel began because we were curious. It accelerated because we were afraid. Fear of falling behind, fear of losing power, fear of being vulnerable. The rockets that carried astronauts were cousins of missiles. The same mathematics, the same propulsion, the same terrifying speed. Even early satellites weren't just scientific tools, they were reconnaissance devices, eyes in orbit. Space was the ultimate high ground. But something strange happened as humans stayed in orbit longer. Astronauts started describing something called the overview effect. Looking at Earth from space changed them. They didn't see nations, they didn't see borders, they saw one fragile atmosphere, thin, delicate, finite. Space travel, born from division, began quietly encouraging unity. In 1975, American and Soviet spacecraft docked together in orbit during the Apollo-Soyuz mission. Former rivals shook hands in space. The battleground had become a meeting place.
By the 1980s and 90s, space evolved again. The space shuttle made launches reusable. The International Space Station became a permanent laboratory in orbit, built and operated by multiple nations together. What started as a race became collaboration. But even that's not the end of the story, because the most recent chapter has shifted once again. For decades, governments dominated space. Now, private companies are building rockets faster and cheaper than ever before. Reusable boosters land upright like something out of science fiction. Launch costs are plummeting. The barrier to entry is shrinking. And suddenly, space isn't just about flags, it's about economics. Satellites power GPS, communication, weather forecasting, global banking. The global economy depends on orbit. We didn't just go to space, we wired our civilization into it. And here's the twist most people don't think about. Every time you check your phone's location, space travel. Every time a hurricane is tracked, space travel. Every time a plane crosses the ocean, space travel. It's no longer extraordinary, it's infrastructure. But the deeper truth remains this. Human space travel didn't begin with a rocket launch. It began with a realization that gravity is predictable, that physics is consistent, that the universe operates on rules we can learn. Once we understood the rules, leaving Earth wasn't magic, it was engineering.
We didn't break the sky, we solved it. And yet, the original motivations, competition, fear, ambition, still echo in modern missions to Mars and beyond. We talk about exploration. We talk about becoming a multi-planetary species, but beneath that language is something ancient. The same instinct that pushed humans across oceans, continents, deserts, and ice bridges, the refusal to accept a boundary. For thousands of years, the sky said no, and eventually, we said, watch us. From Newton's cannonball thought experiment, to Tsiolkovsky's equations, to war-forged rockets, to Sputnik's beep, to Gagarin's orbit, to Armstrong's footprint, to satellites blanketing the planet, the story isn't linear, it's layered. Space travel began as mathematics, accelerated through conflict, matured through cooperation, and now expands through commercialization. But at its core, it's still the same human story. We see a barrier, we study it, we argue about it, we fight over it, and then we cross it. The sky was never the limit, it was just the first obstacle. And the moment we realized that, space travel stopped being impossible. It became inevitable. If this changed the way you see space history, hit like. Subscribe for more timelines where the truth is wilder than fiction. Stay infinite, my friends.